Two, three. Assalamualaikum and a very good evening to all of the people that watch us or watch this presentation. We, Syafi, me, Nizar, Victoria, Peeraga, and Khairi will present about the relation of propagation of light with Maxwell equation. So I will start this presentation by explaining the background of this topic. My name is Muhammad Syafi Haziq bin Muhammad Fauzi. My matrix number is 207771. So what what is the background of this topic? We will explain we'll explain about the propagation of light and also the Maxwell equation, and most importantly, what is the connection between these two. So the propagation of light is intimately related to Maxwell's equation, which describe Maxwell's equation describe the behavior of electric and magnetic field. Also, what Maxwell's equation explains about is the fundamental laws governing the behavior of electric and magnetic field in space and also time. The connection between these two will be explained in the later slide, which Maxwell's equation and the propagation of light is due to the fact that light is an electromagnetic wave. So I will give it next of the show of the presentation to the next member.
Okay, thank you, Syafi. So my name is Pragladan, son of Balamurgan, with the matric number of 205698. So next, okay, thank you so much. So I will make a small recap on the electric and magnetic field, which I'll go through all the equations. Okay, first of all, the Maxwell equations can be divided into two major parts, which is known as integral form and differential form. And the first physical principle under the Maxwell equation is Gauss law, inverse square field of monopole. For the integral form and differential form, the theory that links them for this first physical principle is the divergence theorem. Next physical principle is Gauss's law. Magnetic monopoles do not exist. And for the integral form and differential form equations, the link between them is the divergence theorem. Thirdly is the Faraday's law. Changing magnetic field induces electric field. And between the equations of integral form and differential form respectively, the link between them is the Stokes theorem. And lastly is the Ampere and Maxwell magnetic field caused by current or changing electric field. And between the integral form and the differential form, the vector calculus link is the Stokes theorem. That's all the recap from me. A small brief recap about the equations under the Maxwell equation. So I would like to pass to the next number. Thank you.
Thank you, Peeraga. So now that after Peraga's explanation of the four equations, we are able to see that Maxwell's complete and symmetric theory of these four equations, has showed that electric and magnetic forces are not separate, but different manifestations of the same thing, which is the electromagnetic force. Maxwell's electromagnetic waves are transverse and self-propagating. We say that it's self-propagating because a changing electric field is able to produce a changing magnetic field. And the changing magnetic field is also able to produce a changing electric field. Hence, you are able to say that an electromagnetic wave, such as light, UV rays, infrared rays, visible light, are self-propagating and they do not need a medium to travel through, which is why they are able to travel through vacuum. So I will pass this to the next person, Nizar.
Hi everyone, my name is Muhammad Nizar bin Abdul Halim and my matric number is 207508. So next I will present about the relation in the wave function or the wave So if the wave moves in z direction, which is the electric field oscillates in the plane perpendicular to the z-axis. So the magnetic field also oscillates and is perpendicular to both magnetic and electric fields. And vice versa, if the electric field is oscillating in x direction, we can say that the wave is polarized along the x-axis. But so the figure above illustrate the behavior of an electromagnetic wave, which is polarized along x-axis. So in the previous class, which is Dr. Amira has also shown us how these two relates in a wave behavior. So if the wave is like it's like this, so the magnetic field will go like this. Later we will discuss in the class. So lastly, these waves were first observed by Heinrich Hertz in the late 19th centuries, and they are now known as radio waves, microwaves, infrared radiation, visible lights, ultraviolet radiation, X-rays, and also gamma rays, depending on their frequency. So that's all from me. We go to the conclusion. Syafi, can you tell the conclusion? Voice. Mic.
Sorry. So that's all for our presentation. So for in summary, the propagation of light is intimately related to Maxwell's equation. As we can understand from the presentation by the members of the group, including myself, that uh, propagation of light is related or can be connected, or there is connection between propagation of light and Maxwell's equation. So this describes the behavior of electric and magnetic field. So Maxwell's equation predict the existence of electromagnetic waves, including light, and provide a complete description of their behavior and interactions. So that's all from our group. Thank you, and we will see you next time. Bye.
Thank you.
Thank you.